Welcome to our keynote plenary. It's been wonderful seeing you so engaged and engaging over the last the last day and a half. I hope that you have found these sessions useful and meaningful, and that you have discovered a lot of new people and ideas that you'll be able to bring back to your programs and implement over the next years in your own continuous improvement processes. Before I introduce our keynote speaker, Mike North, I'd like just to take a moment and thank the hotel staff, the ABET staff, and in particular the students from the University of Portland and Portland State University. So please give them a round of applause. They've been doing a ton of behind-the-scenes work to make things go smoothly, and this is really important this time because we've made a record with our attendance this year. We're up to 540 people, so this is huge. So thank you. Yeah, let's clap to that too. So we at ABET have been, in particular, myself and Rochelle Williams, my educational research manager, have been wooing Mike North for the last 7 months to come to ABET. And we're just thrilled that it's actually happening today. He's going to be speaking on a topic that is really near and dear to my heart, and that I've been working on in less visible capacities since the onset of the EC 2000. And that is the importance of preparing students to successfully design in context. So really to engage them in cross-disciplinary, even cross-national collaborations to ensure really that the technical solutions that they propose have optimal impact. And so I've asked Mike to thread as much as he can throughout, and you'll see this in his pictures and stories and examples, how the professional skills criteria across the commissions play out in important ways. And those in particular are, how do the students need to consider the impact of the technical solutions in societal, cultural, economic, environmental, and global contexts, how we need to prepare them to consider contemporary issues of technical and non-technical natures in everything they do, and also, very importantly, and this was underscored yesterday in the Industry Advisory Council, how to help them be successful in functioning on multidisciplinary teams with the ability to not only function within those teams, but to be able to work across disciplines, time zones, cultures, and geopolitical boundaries. And I think that we're well represented in this room to recognize that that's of utmost importance. And so with that, let's welcome Dr. Mike North.
Thank you, thank you. So, was it 7 months ago? Wow. So 7 months ago when I was called by ABET and they told me they wanted me to give a keynote address here, I said, you want me to give a keynote address on education? They said, yeah. I'm like, I'm pretty disruptive in this area. They said, yeah, that's why we want you. I said, okay, well, let's do it. But I also want to show that my slides come up. And I started to think about it a little more, and I thought, well, this is a really amazing opportunity. And I started to get really excited because I kind of realized that this is my chance as a scientist that's been out there in the field for the last 10 years, collecting data on what it's like to be an innovator, being an engineer, being an entrepreneur out there in the quote-unquote real world, to come back to you and give you my report, my findings as a scientist. So just a little background. This is my academic history. I graduated top of my class in engineering, and I guess in some ways I don't want to be boastful, but this is, I'm about as good as you could produce, And then, you see, I went to UC Santa Barbara, and actually, is Glenn here? I don't know if Glenn's here. We often had, Glenn was one of my professors, and he actually really humbled me. He gave me my lowest grade ever on a test, It was my first graduate course, and I remember the day when I got it back, and it was 15%. 15%. The highest grade in the class was 23%. Didn't feel so bad. So that's kind of how I left school, and I wanted to give you a snapshot of what I'm working on now. Just, not everything I've done, but these are my current projects, and at least the ones that I could remember. So I'm founding a global nonprofit called Reallocate, which is pairing talented engineers and designers with real-world problems around the world. I'm co-developing a national design challenge to really spur manufacturing in the United States. I'm working on a project, this is actually a fun one, it's a water quality assessment in the longest free-flowing river in the United States. I just invented a new cooking lid, and I'm founding a housewares company currently. We're in production right now, and that product will be coming out soon. It's called the Convectop. This is probably the first announcement of it ever. It's really cool. You guys will like it. I'm creating a coalition of technology partners to apprehend poachers in Africa. I'm currently hosting a new show. It's out on the Science Channel here called Outrageous Acts of Science. I'm working now on creating a grad course. I'm writing an article for Wired, and the book will follow that. Co-founding a Burning Man camp, which I might touch on a little bit later. I'm coaching at both Stanford and at UC Berkeley. I'm building an online resource sharing marketplace to bring people together and their resources. I'm also a part of a global campaign called Stop the Pity to change how we view the rest of the world and not take pity on them. And then a last little one is working on a community processing facility in Alaska with the potential to disrupt the global seafood industry. So you probably look at that, and how many of you ask, like, how the hell am I supposed to, like, prepare someone for that? All right. So that's what we're going to talk about today, is like, how do you create that? And I feel like I'm a bit of your canary in the coal mine. So if you want to talk millennials, I'm the absolute oldest that you can be for a millennial. I act a lot younger than I actually am. You'll see that. But I can now offer some insight of what's really coming down the pike for you, the millennials that you're having to educate right now. And this generation is different. I border on the X and the millennial. And the millennials are much more about collaboration and cooperation and about community. They don't like being out at the fringes as much. They like to become closer together and work together on projects. And you see that by a lot of these online tools that bring them together. And so this is kind of a pattern that the world's been going in. If you look at my grandfather, he was a professor of botany. And that's what he did. He got out of school, and he went in, and he was a professor, and he had one career his entire life. And he went fishing on weekends, and that was my grandfather. This is my father. My dad actually was probably a little ahead of the game himself. He had about 5 different careers. Everything from leading expeditions to computer programming to owning a delicatessen catering company. So I had a little bit of a varied upbringing myself. I'm actually already up to 5 different careers. So by the time I'm through, I'll probably have had at least a dozen different careers in my life and drastically different things. So it's a matter of not only educating, but preparing students to be able to adapt to a wide variety. Now a millennial gets out of school and it's like 2 years they're in one career and then they switch. It's really amazing turnover. So I'll just go over a couple of the careers I've had in the last few years. After grad school, I kind of had this moment, actually. I was pushing so hard, and I'm going to get my PhD thesis done, and I finished it, and my defense committee said, yes, and then I was like, all right, now what? Oh, didn't think through this. And I was looking at tenure-track professorship, and that was an option. There was industry, and I'm like, oh, gosh, I don't know what I want to do. And so it was a great day. I was just doing a postdoc to kill time. And that's what all postdocs are doing, by the way. They're just killing time. And I was killing time, and I got a call, and it was kind of like this. Like, hello? Yes, this is the Discovery Channel. Hi. Would you like to host a TV show, Building Crazy Machines? Yeah, that sounds pretty good. And so went on to not only host, but then put together this TV show called Prototype This. And these producers had no idea what they're doing. They're like, well, this is what the show is. We'd like to invent things that everyone wants, no one's ever seen before, really hard to make, and are spectacular on television. What did I say yes to? And, well, for editing purposes, it's nice to cut between two different projects that are happening simultaneously. I'm like, okay. And we'd like to do, an episode every week. So no touch with reality. So I got to come in and bring some reality. We got down to doing one project every 2 weeks. And when you look at the projects, you'll still say, how in the heck did you do that? But one of the most significant things that came out of the show was the impact it had on kids and inspiring them. And this was a letter I got from a kid. It says, I'm still in school and I'm studying science. It's fantastic. I hope to get my PhD one day. I also plan on doing further studies in engineering. I hope to become like you guys one day. I'm a huge fan. Give my regards to the rest of the team. And I read that, and that really touched me. And I even got stopped on the streets of San Francisco by this guy, and he just graduated, and he said, I saw your show, and I went back and I went to engineering school because of it. And when you look at what we did, you can kind of see why. So this is one of our projects. These are 10-foot-tall, pneumatic-controlled boxing robots. Cool. It was a cool job, I gotta say. And the way it worked is you would stand outside the boxing ring with your boxing gloves on, and they had accelerometers in them, and then we had an optical glyph on your back that could track you with a camera. And when you'd swing your arm, the robot would swing its arm. When you move your torso, the robot would turn its torso. And so we had 2 of these, and they would duke it out in the ring. And this is way before that movie, Real Steel. So long before. Now there's actually, I hear, a competition like this. This is another project, just a little project. This is a completely custom 6-legged vehicle. Some highlights on this. Well, let's see, it's an all-custom chassis. The battery packs actually have a custom-made BMS where we actually had to make the circuit boards for each of the battery cells. There's the gearboxes, and then there's these carbon fiber legs on there. Those carbon fiber legs were completely modeled. They were layered, 150 layers, laid just right to give you the right spring and the step of this vehicle. And when this project actually took us, we actually went over. It took us 4.5 weeks. Yeah. It didn't work, but it was close. We needed like another week, and that wasn't enough for TV, but we had it standing up. It was just in the control system. This you might recognize is the Google self-driving car. It was actually on our show first. And you can go online, by the way, and watch Prototype this on Netflix if you want. I'm not going to show a lot of video. But this was actually before it became the Google car. And in San Francisco, we shut down the Bay Bridge and had this car drive itself all along the Embarcadero and over the Bay Bridge. When you shut down an entire bridge, it's kind of a cool feeling, I have to say. This is another project. This didn't air, so this is the pilot we made. So this is a bike, so it's not stolen in San Francisco. Bike theft's a big problem. Has some security measures inside of it. In the headset, there's a little lock. There's the battery pack. The pedals, we have these spikes that go up and catch your feet. In the seat, there's a RFID reader and an accelerometer, and then a whole electronics package there. So basically, someone comes up, it's not their bike, they sit on it, all the internal alarms go off, they're riding away, think they stole this bike, their feet get locked into it, and then, let me just show you a little video on this one.
The steering locks, the rear brake triggers, and Tim's shoes are taken prisoner.
Oh, poor Tim. When we were conceiving the show, we were like, oh, we're going to have these crazy machines. Who's going to test this? And we're like, oh, there'll be that guy standing in the corner of the shop eating a hamburger. Hey, guys. Oh, we'll call him Tim. Yeah. Hey, Tim, why don't you come test this bike? Oh, okay, guys. So the day we go to test that bike, they bring in the stunt guy. And I'm like, hey, I'm Mike. And he's like, hey, I'm Tim. I'm like, oh. This is too perfect. That wasn't the worst thing we did to Tim. This was another one of our ideas. This is the personal airbag. I think it kind of describes itself. Clearly, you feel safe when you put this thing on. Here's a little video for Tim testing this.
3, 2, 1.
It worked. It worked really well. And there's a lot of engineering in that. You know, there's sensors to detect when you're falling. It says, okay, if I like fall off of this, that might sense it, but another foot and it would definitely trigger it for going off, right? Because you don't want people just to step off and have these things go off. There's baffling inside the bags, or there's carbon Kevlar reinforced bags. But when we did it, it worked so well the first time that the producers are like, that's amazing. Let's take off the safety rigging, because he had some safety rigging there. And I was like, yeah, this thing really works. And the stunt coordinator's like, well, no. Well, we can do that, but you got to bring him down lower, right? So they bring him down, take off all the safety, and they put him on the scissor lift, right? And they're raising him up, right? And he's going to do a swan dive off this thing. And they get to about 6.5 feet. And the stunt coordinator's like, no, he can't go any higher. It's not safe. And I'm the engineer like, you got to go higher. You got to go higher, right? We've all figured this out already, right? Let's see. It takes a little bit to detect. There's probably a little bit of deploy for the airbags to inflate. So we all know what happens. Poor Tim. I lose the argument, of course. Tim jumps off, hits the mat flat on his stomach, and then the bags explode and shoot him up in the air, right? This is probably the craziest thing we built. This is a 30,000-pound water slide simulator. Say that one fast. Water slide simulator. I was in Japan presenting on this, and I was saying, and no one knew what a water slide simulator was. And so I had the translator translate it. And I'm like, could you translate water slide simulator? And the translator like, water slide simulator. And the whole audience is like, oh. It's, this communication thing, So this thing was pretty sophisticated. The whole thing spins, so it's like a perpetual water slide. And then the whole thing moves up and down and side to side. And it doesn't do it randomly. We would actually draw on the computer, right? We would actually create a model. And then we would do a Nastran simulation of the particle path that a human would take going down that water slide. And then our control system would seek to put you in that same part of the water slide as you're going down this. And then we'd also project in front of you what you would be seeing. And the thing was magnificent, and it was a little scary.
Joe starts down the virtual path. And as the simulator tilts and whirls, he's loving every minute of it.
Sounds like he's having fun. Yeah.
The simulator programming puts him through a series of 10 360-degree turns on a ride that lasts a full 3 minutes. Over 10 times as long as a traditional water slide.
Oh, he's just having a good old time in there.
And as the simulator completes its maiden voyage, Joe emerges unscathed, the inaugural rider of a thrillingly successful prototype.
It felt like the longest, fastest, craziest water slide ever.
The thing was pretty cool, I gotta say. I don't know how I convinced them to do that, but, and one of the things I just want to highlight from that project is, here's kind of our welding team here. And if we were to fill in the rest of the circle, we'd have all the different designers and engineers and even like the conceptualists, and it was a group effort. We built this thing in 5 weeks, right? So it's breakneck time, but it took a lot of people coming together, having to collaborate, and that was a lot of what we did on Prototype This. Crazy idea, figure out basically the basic design of it, and then go and find all the different resources in the world, all best-in-class industry partner, academic partner, and then bring them all together and then execute over a short period of time to create these things. And that was our kind of our philosophy. So after the show, I kind of said, what do I want to work on now? What do I want to apply this kind of knowledge to? And I decided to really look at 2 different things. One was climate change, kind of a little bit of an issue I wanted to focus on, and the other one was education. So I was debating between these, and as any good millennial, when you're debating between 2 different things, what do? You do both, all right. So I did both. So Newco Toys was aimed at the educational side, so this is an educational video game / toy company. And one of our first projects was And you can download, we have Animal Planet and Monsterology. They're both in the App Store, and you can go to the Apple Store and buy trading cards. It's pretty cool. I don't want to talk about that. I want to talk about the education stuff. It was Mission to Planet 429. So this was a video game intended to get kids past the 4th grade reading slump. So that slump is when kids go from learning to read to reading to learn. You know, it's not just about figuring out how to read, it's figuring out how to go to text and get knowledge out of it to do something. And it's a huge issue, right? And so our approach to that was to start on planet Siren. And on planet Siren, they have their World Explorer Federation. And the World Explorer Federation, who picks these names? Their goal is they go and explore the galaxy, and they discover new planets, and they learn about them. And they just discovered planet 429, which is planet Earth. And so as a world explorer, and this is now you, the kid in the video game, you need to go down to Earth, and you have to explore this carnival. And the reason being is that 2 of your coworkers are trapped on this rocket ship ride, which was a spaceport. And so to figure out how to fix a rocket ship ride, you need to learn about simple machines. In order to learn about simple machines, you need to find magazines and books and posters around the carnival. And you have to read that, and you have to gain information from it to then be able to fix it. And the results are amazing. We go in to these low-income inner-city schools. One I went into was Chicago. Kids couldn't sit still. And then all of a sudden you put this video game in front of them, and these kids are totally and completely engaged in what we're doing. I'll show you a little video from the...
Your job, your only job, is to collect information while you're playing to help them send their information back to where it has to go to their planet.
I think the game was a huge success. A huge success. I've got kids now who initially weren't strong in decoding and trying to actually figure out words and the meaning of words. That's all they want to do.
We're gonna teach you how to play this.
And you're at the carnival, and you have to read every sign that you see. So you have to read this, and it tells you the different things that you have to do to say Gilder and Zorna. And if you didn't know how to say the word, you just click on the word, and you could tell them say it, explain it more, or more help. See.
I'm starting to see some of my non-readers perk up. My students who aren't necessarily interested in reading, they're coming alive. With Planet 429, they are asking for help. It's really, really exciting to see them, the wheels turning in their heads and really, really taking the step forward. I'm seeing drastic improvement with just the overall interest in reading and what they're able to do with those skills and strategies that I'm teaching them in class. They're engaged completely. I had a student the other day and says, "This is education." And I'm like, "What do you mean by that?" And I had another student say, she means she's on the edge of her seat. And when he said it, I'm like, that's actually a nice line. Education on the edge of their seats. And I would not have thought in a million years that I could allow my kids to play a video game and they still learn. This is major. This is changing the face of education completely.
It was fun. The game was fun. And I got to learn something different.
And one of the girls in there, she excelled beyond all the others. And I didn't know her history at all. I'm like, wow, that girl really, she's picked this up, she's in there, she's reading. She was like head and shoulders. And I went to the teacher and I said, wow, this must be your top student. She's like, what? I'm like, yeah, she's outperforming everyone else. She said, she's been held back twice. She's my worst student. And I wanted to bring this up because, I went to a session on online education yesterday. And, online education is amazing, right? And it's totally changing it. But it's still in its infancy. Like the technology, it's like web pages, right? Right? It's kind of like, a black and white movie kind of thing. Wait until gamification comes in. When you're in these worlds with physics simulators and everything like that. Now really think about that. So I just wanted to point that that's coming down the pike as well. And, and it's a great way to engage people. Last night we were at dinner and they're like, oh, my college students, I don't know if I could get them to play a video game. I'm like, really? So climate change. So what would you do if you wanted to, you know, help slow climate change? Well, this is what I decided to do. Build a really fast electric car. I also like doing things that are fun. And so what I wanted to do is I wanted to be able to basically change public perception on what an electric vehicle is. So that when, you know, in 5 years, or I guess now, when Joe Sixpack goes into the Chevy dealer and he looks at the Chevy Volt, he doesn't look at it and go, oh, that's one of those sissy electric cars. Looks at it and goes, wow, that's electric. I bet that thing's really high performance. And so that's what we created. And this is a 1933 Ford replica. So it's all fiberglass. It has a race chassis on the bottom. And since we're all kind of engineers here. Oh, by the way, when I say engineer, I'm a material scientist and engineer. I'm the CTO of a video game company. So, and I kind of, to the rest of the world, class myself as a technologist. So it's, you know, engineering, science, technology, and computing all wrapped in one. And to me, it's like that is one discipline now. I'm out of this. When I say multidisciplinary, just for reference, I mean business, anthropology, engineering. That's multidisciplinary to me. And so this project here for the engineer, scientist, computing, and technologist, I'm not going to say that every time. 440 volt pack could put out 2,000 amps of current. That's for the electrical engineers. For the mechanical, 660 foot-pounds of torque at 0.1 RPMs, and the car weighed 2,000 pounds. The first time we took it out, we got 0 to 60 in 3.8 seconds. And it looks pretty good too, right? So I've saved it to the very end, and you may have to remind me. I have a video of this, so if we have a little time, I'll show you the video from the car. Now the thing that I'm really focused on is a nonprofit, and I even hate that word nonprofit. So it's a for-purpose company. We act like a startup, but we're a 501c3. And what we're doing is we're really trying to bring together these huge talent pools. Like there's a huge talent pool in this room, and the access you have to engineers, scientists out there that could do real good in the world is amazing. And there's also a lot of real-world problems out there. And so figuring out how to put these together is what the project we're doing. And when we feel what happens when you put those together is we can take real-world problems and we can create just life-changing innovations. And then for the people that work on that, it brings this deep, profound sense of meaning to their lives. And this is a great way to engage students, by the way. I went to Kathy Leslie's talk earlier, Engineers Without Borders, and they're doing just tremendously great work. And they gave a sneak peek at this educational online thing they're doing, which you definitely all want to tune into. So just an example of this, and this is how I got started. I was approached by a board member of the Miracle Feet Foundation, and they're trying to treat kids in developing countries with clubfoot. So 250,000 kids are born a year with clubfoot. 80% of those cases are in developing countries just because of the birth rates. And there's a non-surgical treatment method that's 98% successful, but they have to wear this brace. And the problem is that the braces are expensive. You know, $1,500 is low. It can be $5,000 for the bracing, which, you know, here in the U.S., you know, over 5 years, amortize $5,000 so your kid can walk is nothing, right? But developing country where you don't even recognize that this is a problem that can be solved, it's a no-go situation. So they came to me and said, hey, would you want to reinvent this? And so I went out and worked with some different partners, a 3D printing company, Autodesk, Tech Shop, and reinvented this brace. And so brought it down to less than $50 total bracing cost. And for me, when I was down in Nicaragua here, just that moment when I was like, all of my expertise in engineering and my connections and my network put into this brace and then put that onto this kid's foot. And it's like, this kid's going to be able to walk now. This is totally transforming a life. That brought just a deep, profound sense of meaning to my life. And now what we're doing with Reallocate is sharing that with people around the world. So we're starting to build out a global network of people that really care, interested, and want to work on these projects. So that's kind of my projects I've done. And I thought I might just kind of give you a little, like, how did I get to the point of being able to do all these things and walk you a little bit through my life. So my education started at the University of Wyoming. All right. Yeah, I was a great student. I was a little younger than you might think. They have is prep still there? All right. So prep is for university employees. Their kids can go to this school, and it's basically an experimental school. That's how I remember it anyway. And you get these great TAs that come down, and then you have these just fantastic teachers. And one of the things I remember most was it was a very self-guided educational experience. So it's kind of like lectures, but then there were workbooks. And I was doing algebra in the 4th grade, like full-on algebra, just because these workbooks were fun. And I would just keep going through them. I loved it. And then, I moved to California, and I love California, but I moved to California, and I didn't learn any math for 3 years. And then I was in the advanced placement whatever class, even at that point. And there was something to that self-guided, which I liken to this online education. But growing up in Wyoming had a few things to it. We had a cabin up in the mountains, this snowy mountain range. So, and this is not like a cabin that I see with people in California. I'm like, that's not a cabin, that's like a resort hotel. Our cabin was like logs, and there was no bathroom inside, there was a privy outside, there was no water, you had to hike a half a mile to the spring to get the water, there was no propane, you had to literally like go get the firewood during the summer. It was a pretty intense experience, and you'll notice I'm going to start to bring in this little badge up here. It was a pretty extreme environment, and my father is taking us up there, and, this is me back here on a snowmobile. I'm probably 5, and I got to ride my own snowmobile, That's, by the way, the same age when I got my first gun, So I didn't get a shotgun until I was 7, all right? And there was something about being out in the outdoors and be able to, like, experiment. And my parents were very kind of liberal with me. This is a picture of me building a fort. And my mom, she asked me, she's like, well, oh, honey, what are you doing? I mean, we're up in the mountains, and there's lots of wild animals and really remote. I'm like, oh, Mom, I'm building a secret fort. I'm going to go put it out in the forest where no one can find me. My mom was like, oh, that's nice. I go hiking off with hammer and wood and built this fort. It's actually become a lore that some cross-country skier got lost and survived in this fort that I'd built when I was a kid. I was really into forts. This is a fort. The bottom of it was 8 feet off the ground. So there was a certain level where my parents allowed me to take risks. And I think that this was really important in my development, in allowing to like push boundaries, but also being okay to try things and to let them fail. And that's where you kind of discover a lot of your early childhood creativity. And this is something that I think we need to foster. From Wyoming, I moved to Petaluma. Petaluma is known for American graffiti. So you can now make a close link between these electric hot rod that I built with my upbringing. And, quite frankly, my hands-on building experience came not from my education, but it came from taking cars apart and taking engines out and building them, and this kind of like outside activities that I was constantly having. My ability to work in teams came from my parents owning a catering company, and so I would go out, and as I grew older, I would manage kind of different teams of people doing different things. And these are really important life skills that need to be infused in what we do. After high school, I went off and moved to Sweden. Actually, it was my junior year of high school as an exchange student. And a lot of people ask me, why'd you go to Sweden? And I go, why not, I mean, it's cold and all that, but as a 16, 17-year-old boy, there was definitely parts that it had its perks. I didn't discover that until I got there, but there was a certain risk that I took in doing that. And then, of course, I came back and I had to make up some credits, and so I started at the junior college. And it was here at Santa Rosa Junior College that one day I decided, you know what, college is not for me. And I told my parents that. And I packed up 2 suitcases, and I got on a train and left for Boston. And that was it. 6 months later, I was back in my hometown shoveling gravel at a landscape construction job. Literally. Like, 6 months later, I came back, and I spent the day shoveling rock into a wheelbarrow, and then wheelbarrow down a plank and into a hole. And that's what I did, mind. And because I was so bored, I was sitting there calculating, the volume of the hole, the volume of the rock, This is way before I even knew anything about material science. I figured out the packing factor. I was like, and at the end of the day, I had gone through all this math in my head. I'm like, I just kind of looked at that pile and I was like, you know what? I think there might be a little bit more out there for me in this world. So then I went back to Santa Rosa Junior College. Did good, and then from there, transferred to UC Santa Barbara. If you go to UC Santa Barbara, it's written in your contract that you have to show this picture every time. Actually, the engineering department is right down here. So it's some nice waterfront property that we have there. And at Santa Barbara, I kicked butt, you know. I got every different award. You could get distinctions in majors, the honor societies. I got a bachelor's, a master's, and my PhD. And this one is actually the one that meant the most to me. And it's probably, most people wouldn't, but this is where your classmates actually vote on who the top student was. And my classmates actually voted me in. And that's what really counted. Just like, but it's also because they knew some of my other activities. So kind of in the background to this, I was also doing things like building Viking ships. So most students, after they graduate from college, they get some money. My grandmother gave me $500. And they usually go to Europe or something like that. I'd already lived in Europe. I'm like, you know what? I'm going to build a motorized Viking ship. And so I got a truck. My buddy Telef here cut it up and started to build out this kind of endoskeleton to it and made a 28-foot long Viking ship in Santa Barbara, and then drove it all the way out to Nevada. Actually, I hold, this is a little known fact of me, I hold the world's land speed record for a Viking ship. Thank you. And just the moment as I'm setting the record, it's like 95 miles an hour. And this thing's kind of floating, and you're like, I don't know if this is such a good idea. Just as I'm doing that, I look over, and there's a highway patrol right next to me, and I'm like, and he looks at me, he's like, he just kind of shakes his head and just drives off. It's probably because he realized it had a flamethrower on the front of it. Notice the risk got a little bit bigger here. And this is something kind of that carried into my PhD work. So my PhD work was studying the gecko and learning how the adhesive found in their toes and their tarsus work. So I won't go into the science behind it, but it's a pretty cool biomimicry, nanoscience problem. Do people want to hear about it at all? So basically, a bunch of little hairs, they split out into finer and finer points, and it creates a phenomenon called contact splitting. And through that contact splitting, you actually enhance the amount of adhesion you can get through van der Waals interactions. Van der Waals interactions are near-field forces, which are they're a temporary disturbance in the electron cloud that causes near-field interactions to attract. Basically, you got these small little spatulae and onto the surface. And during my PhD, though, I wore this hat, and it said on it, frequent failure. And I loved wearing it around. And all of my classmates were disgusted by it. They thought it was so wrong. Like, how could you want to fail? What are you doing? I'm like, no, man, failure is cool. That's how you learn, right? And it was totally just like this abstract thing. We've trained, our education have trained that failure is not cool. We've trained them that you have to get a good score on that test, that it's not okay to fail and then find out where you went wrong. And that was something that I found time and time again. And, you know, I don't know if you know, in the entrepreneurial world, there's something called the lean startup method. And this is what almost every startup company is based off of these days. And one of the core principles of the lean startup is fail fast. That means you go in and you try something immediately, and you don't spend a lot of time before you find out that it's going to fail. You know, don't spend 5 years just figuring out that that was the wrong course to be on. Go in and find that out immediately. And that was something that I actually did throughout my PhD. I was in a clean room, and I had the best advisor. She just let me kind of play around and try a lot of different things. And in a very short amount of time, I iterated and iterated through a lot of different failures, but ultimately ended up making this microstructure. So these are like 20 microns on the side here. And then this has these aligned 20 nanometer aligned vertical nanorods on top of it. And what this is now an electronically addressable surface that I can change the conformation of to change the adhesive properties of it. It's pretty cool, and all done using the same equipment we use to make computer chips. Well, while I was doing this, I got an email, and this email went out to the entire engineering department. Actually, it went, I think every engineering department at every university in the United States got this email. And it basically said, do you want to go to Australia? I said, yes. Do you want to be on a TV show? I was like, yes. And building machines that mimic animals. I'm like, wow, this is amazing. And I was so excited that I went out and I produced my own video, like a casting tape for it. Because you had to get into this program. It was to make a TV show for Animal Planet in Australia. And I spent a lot of time and energy on this. It made something that was really dynamite. And what was really interesting, though, is I would ask all my other, after I submitted, I asked all my other classmates, I'm like, oh, cool. What, did you send in your application for that TV show? And every single one of them said, oh, well, no. I'm like, what do you mean? They're like, well, I don't know. I probably wouldn't go on a show. I'm like, you don't want to go to Australia? Oh, I'd love to go to Australia. You don't want to be on a TV show? I'd love to go on a TV show. Why didn't you submit an application? Oh. And I think there's a risk factor. For me, it was like, I went to Sweden, because, well, why not? Why not go to Australia for a week and be on a TV show and just do it? So where is that it's okay to take a risk? So I went off and I did this show called Chasing Nature. It's an Animal Planet show, mimicking animals. And what was interesting for that is this is what led to Prototype This for me. And through this show, they had 13 episodes, and they had 4 engineers per episode from students from all over the United States. And the producer of Prototype This, the discovery show I did, went to the producer of Chasing Nature and said, okay, you had all those engineering students. Of those, could you give me, a short list, 10 students that you think would be good hosts for this new show about building these crazy machines? And the producer of Chasing Nature said, it's like, well, actually, out of those students, there are only 3 of them that could build anything. And there's only 1 that you'd want to work with. And that's why they called me up and offered me the job on the spot. And so it's really remarkable, just kind of builds it in. And so that's how I ended up in a field in a 6-legged vehicle. So this is Larry Page, founder of Google. I think it was part of that training of not following rules and orders and being self-motivated, questioning what's going on in the world, and doing things a little bit differently. This is what really kind of led to him. And I put up a few kind of our outstanding entrepreneurs. Do you know what all these people have in common? So Jeff started Amazon, Jimmy does Wikipedia, Sergey and Larry, Google. Do you know what they all have in common? They all went to Montessori School. At Montessori School, I looked this up, I actually found out that Alexander Graham Bell was a big proponent of Montessori School, Thomas Edison, even Mr. Rogers is a proponent of Montessori School. And one thing I found is that a core principle, and by the way, my mom that I lived with in Sweden was studying to be a Montessori teacher while I was there. So I basically got a little bit of a Montessori education. But central to that is that it's play, and that kids learn through play as they go through life. These 3 guys all have in common, they all dropped out of school, right? Sorry, just want to throw that out there. So, and then there's this thing. All net new jobs in the last 5 years have come from startups. So I did some little statistics here. And there's lies, damn lies, and statistics, so I acknowledge that. But I looked at 58.2% Americans work. 37% of under 30-year-olds households live in poverty. And this is in the United States. 15% of the population is in poverty. And 70% of our economy comes from consumer spending. And in 2009, 51%, this is the tipping point, of U.S. patents were issued to non-U.S. companies. So this notion of innovation is a big issue. You have the president talking about it. In America, innovation doesn't just change our lives, it's how we make a living. We need to out-innovate, out-educate, and out-build the rest of the world. They did a survey of 1,000 executives in the country, and 95% say that innovation is the main lever for a more competitive national economy. 88% say innovation is the best way to create jobs. 77% say the greatest innovations are those that address human needs. There's a lot of human needs in the world, too. There's 3 billion people that cook over an open fire. It's like a death every 16 seconds. For kids, so kids under 5, they hang out with mom while mom's cooking. They hang around the fire and the smoke. It's equivalent of between 2 and 3 packs of cigarettes a day that those kids are smoking. So there are huge global issues the whole planet's facing. And I'm a big fan of Buckminster Fuller, but you know, really we're looking at Mars and we're going to go live there. I'm like, we have a perfectly good place to live here on Earth, and we need to take care of it, right? And one thing, a little pause. Who's going to take care of this? It's us. It's the engineers. It's the scientists. We're the ones that actually know what's going on, can figure it out, can develop solutions. And we play such a significant role in this. And this is something that clearly we need to be focusing on and are. And we're going to do it by creating innovators that do it. So the world doesn't need more people with good grades. The world needs people who see the really tough problems as puzzles and have the tenacity and creative capacity to solve them. So while I got really good grades, you know, there are other ways that you can go out and like create, be inspiring, innovate. Here's one of my favorite things, and this is another thing. I'm glad Glenn's on here. This was the night before I took my quals. I was actually out doing this. So that's how I like to inspire people. I cut the roof off my car, I put 50 pounds of propane in the back seat, put on 8 fire cannons, hook it up to a computer, and then go to downtown Santa Barbara and do a show. And you know what it does? It changes people. It opens up their imagination, and it's a great thing to do with students. And now they're letting me actually work with students. This is I'm working with a team at UC Berkeley. We're working on this Alaska project. There's our Alaska partner there, Dune Lankard, one of Time Magazine's top 50 heroes for the planet. It's really cool. Get like these energized students that really want to make a difference in the world. And this is my favorite part of my entire talk. I get to give all of you assigned reading. Read this book. Read the first chapter. It's amazing. It's a great book, and it really shows about not only the need for creating innovators, but how we go about doing it, how we go about fostering it. And it's something that we all need to be doing. And I know we're all in our structures and our rigors, but this is the utmost importance for our country and also for our world, what we're doing. In the book, he says, China now requires every college in the country teach the skills of entrepreneurship. And K-12 education reforms are de-emphasizing standardized tests and doing more creativity. This is China, right? China, where you see the regiments. I'm seeing this. China's like, whoa, we want to be more like the U.S. We want to be, creative and innovative and entrepreneurial. And meanwhile, the U.S. is really pushing more like standardized. We got to do this. And I know there's a lot of reasons for that, but it seems crazy that this is the direction we're heading in. Even the National Academy of Engineering, the engineer of 2020, is going to have these qualities: business savvy, culturally aware, manage complexity, possess leadership and communication skills. And I'd like to add on to that you have these millennials, right? They're all about collaboration and cooperation. And so when you look at I love Maslow's hierarchy, right? So we all know this, that before you actually get to this point where you can actually really do anything significant and meaningful, you need to have your basic kind of needs met, right? And I think that for these millennials here, there's kind of a new paradigm. This is what I call North hierarchy of innovation. And instead of at the top being self-actualization, it's cooperative innovation. And it's where we're all working together, multidisciplinary, working together to come up with solutions. And now there's kind of this basic needs you have to be met. And I fully acknowledge, and I love my education. My education is the single largest investment I've ever made in my life. So it's very near and dear to me. And it's very important with who I am. And that's why I put it down here at the base. But now with that, there's also alternatives. And as an entrepreneur, I don't see a problem, I see an opportunity. And a lot of people are seeing this opportunity with online education. Here's Coursera. I actually looked last night, and it's at 3.25 million. So, and that's just in the last week and a half that it's grown. So online education is growing. There was a whole session on it. We have Udacity, and then also major universities are now getting involved. And even my little JC, right? Well, it's not so little. It's like 40,000 people, but is on iTunes. So when I see this education, I say, wow, you know, this is a great place. Online, let them handle that. Because you know what? It's kind of a headache for us. This is the student here, and this is you as the teacher. I don't know. Why not focus on this side? So I think there's a huge opportunity here for universities to stay relevant. How do you create a physical place, and where's the relevance of it? Well, it's relevant in all of this, because this is hard to do online. And this is the point where you learn. I'm a biomimicist, right? So I love studying nature, taking lessons from that. So in nature, you're a little cub, and you start to play, right? And then you play a little bit more, and you play a little rougher, you know, and then you learn that, yes, you can fail, but you still survive, and then you're out hunting. I see this as a continuum, a continuous transition from play into work, and there's no hard stop, right? And I feel now what we have is a system where you're a kid, and you play and everything like that, and then you go into school, and then you get into your testing, and we gradually stop learning how to play, and then you get to this point where you've taken all these tests, and you've learned all this material, and then there's this hard stop, and you graduate, and now it's like, now go be in the real world. And I feel that there just needs to be this transition that moves you through that. And I've actually attended a few of the talks, and I've seen some great work that's being done, these integrated courses where now they're project-based and everything like that. But it needs to be that transition as we move them into industry. Engineers, I did some interviewing of engineers before this, and they said, yeah, you know, I learned all that. It was a great foundation, but my first job is when I learned everything. And to me, it's like the university has this opportunity to provide a safe place for students to play and fail and learn, and then take those lessons out into the world, right? But it's a transition that you move through. And so play is so important in that. I want to run through just a little bit of like how we can foster this. If you've seen this, this is a Stanford team. They said, oh, what do we want to do for a year? And so they went out and they built a truck. And they put all this, and they drove around the country with all these 3D printers and laser cutters and everything inside of it. And they went around inspiring kids to play, to create, to get their hands on things. Take risks. This, I don't know, that seems like a small risk to me, but the student definitely has that look of risk in his face. And that's what they do. And then this can be a transition. So this is actually inside Tech Shop. So you can see now grown-ups here are actually transitioning all the way through this entire continuum. And it comes to the other phase, is collaborating. To get that waterslide simulator done, it took an enormous team of people working together and building those skills. And there's another trend that you see. This is a map of hacker spaces in the United States. And this is growing rapidly. So these are people in communities that are all now coming together just to create and to build that community spirit to create. This should be universities. Universities should own this. This should be a space where people come in, and you have people from industry and the outside and kids, and they're all working together to innovate and collaborate. If you know Tech Shop is springing up. There's 8 locations in the United States and growing rapidly. So these are facilities with machine tools and 3D printers and laser cutters and community working spaces. And I bumped into the CEO of Tech Shop last week, and I told him I was going to give this talk. And he said, universities are really interesting. He goes into universities and he finds out that each, like mechanical and electrical, they all have their own shops, and they're all separated, and students can't share. He he said they're probably going to end up going into universities and pulling that all together, consolidating all those resources, and then they're going to run it. And now it's going to be this kind of cross-disciplinary place where people can actually work on projects together. There's a huge maker movement happening. I'm sure we're all aware of this. It's spreading all over, New York, Orlando. And this is people's basic desire to create and make. If you could infuse this with education, I mean, it's limitless. There's a lot of this is just hacking. And hacking, to me, is kind of like just kind of figuring out, but if you had an educational base on that, the power could be amazing. And then creativity, which, by the way, is really, I think, what I associate all these risk experiences that I've been sharing. I think so much of that is where you find your creativity. This is a recommend. This is not required reading, but this is a recommended talk. Ken Robinson gave a TED talk that I highly recommend watching. But he says, I believe this passionately, that we don't grow into creativity, we grow out of it, or rather we get educated out of it. And even Einstein, imagination is more important than knowledge. And the need to bring creativity. Back to that survey, it said 58% say creativity, of these executives say creativity is the #1 contributor to innovation. A recent IBM poll of 1,500 CEOs identified creativity as the #1 leadership competency of the future. Like, I'm sorry, I love science and engineering. I want us to lead this world, right? But we need to have creativity and innovation in what we're doing if we're going to be able to have a seat at that table. Creativity is not some exotic optional extra. It's a strategic issue. And this has gotten in the press. Here's and on Newsweek, Creativity in America. So when I look back at my recollection of creativity, it was my mom that allowed me to go build that fort out in the middle of the forest. I don't know what she was thinking. But and it was, when I just decided to build that Viking ship. My nonprofit, we did a program where we brought at-risk high school girls into tech shop and taught them silk screening. But just bringing them in, it changed them. This is Sabrina. I asked Sabrina before the program, I'm like, Sabrina, where does stuff come from? Walmart. I asked her, now where do you think stuff comes from? Oh my God, I'm going to make jewelry. I'm going to start a jewelry business. I'm going to make it. I was like, wow, totally transformational. So just that exposure transformed this person's life completely, forever. So I see this as kind of a holistic approach you need to bring. You need to have the education there. You need to have the creativity. You need to have the collaboration. And then, oh, I already said creativity, the play. And that's what got me to being able to do something like this, and prototype this. This is what has led me to have a nonprofit that's trying to solve these global issues. We're building an online platform now where we're going to bring people together, where people can put up their opportunities. We don't call them problems, we call them opportunities, very entrepreneurial, bring it together. And through the course of this last 7 months preparing for this talk, I've really started to look in this field and am now actually going to be teaching a course at UC Berkeley on this. And what I want to do is, I don't want this to be my course or whatever. I want to just take this and I'm going to open source it and try different things. And I want to hear from all of you what you're doing and start to experiment and build that prototype and iterate on that prototype and make it available so we can create this thing. We can create this innovation engine. And we can do it not just for our schools, but we can do it for the entire country. And quite frankly, we can do it for the entire world. Because the world has a lot of challenges ahead of us. And I want us scientists, engineers, technologists, and programmers, I want us to be the ones out there leading the charge. Thank you. All right, does anyone want to see the video in the car? All right. So this is, again, risk factor. 440 volts at 2,000 amps DC, all right? A little dangerous.
We're still cranking tires, and we're now in the middle of our track time. We only have an hour on the track to get this right and see if she runs well. It's a little thick in there.
I heard a rumor of a sawzall. Is that true? Infineon Speedway, world famous, testing out the car. We're not just testing, we're racing them.
You get to hear what the car is doing and what it's trying to communicate back to you. And as a driver, that's really what you need to do, is you have to understand what the car is trying to tell you. Well, this car is just talking to me the whole time. I'm not unbelievable to drive. The throttle response is just there. The car's there.
Amazing!
I'm really upset I can't go for a ride on the track.
That's awesome!
It may take me a month to digest all this and go, yeah, I was like, no, it's over the top. Unbelievable.